Hi, everybody. In this video, we're going to look at section 1.6, which talks about other types of equations. So it's kind of a mishmash of different style of equations that don't really need their own chapter. So they're kind of put all together in this one section. So we'll cover a few different types. One type we're going to look at is a polynomial equation. So a polynomial equation is the result of setting two polynomials equal to each other. So we're allowing for exponents here. The equation is in standard form if one side is 0 and the polynomial on the other side is in descending or decreasing powers. The degree of a polynomial equation is the same as the highest degree of any term in the equation. So I'll show you how to do degree as we go through the examples as well. We're focusing on polynomials in one variable, so just in x. When you have polynomials in more than one variable, then the degree gets a little bit more complicated. But for our purposes, if you only have one variable, it's going to be pretty simple. Now, for polynomials, not every polynomial is factorable, but for the ones that are, we can solve those polynomial equations by factoring and using the same techniques we did when we solved quadratics by factoring. So let's look at a couple of those examples. So first, here is our polynomial, and I'm going to start by putting it in standard form. So that means I want to have one side equal to 0. So I'm going to bring this to the other side here, and you can do that by subtracting it. 27 on both sides. So we have 3x to the fourth minus 27x squared equals 0. So this is standard form. One side is equal to 0 and my powers are in descending or decreasing order. Now for the degree, what you do is you find the degree of each term. And if you just have one variable, then the degree is just the highest power there. So the degree of this term is 4. And the degree of this term is 2. If you have polynomials of in more than one variable, it gets a little bit more complicated. So just as a little side note, let's say I had a polynomial that was 3x to the fourth y squared minus 27x squared y equals 0. Well, in that case, when you do degree, you add up the exponents within each group. So here your degree would be 6, and here there would be a 1 here. So your degree would be 3. 2 plus 1 is 3. So just a little side note, we're not going to solve anything like this today, but when you're talking about degree, you do add up the exponents on the variables within each term. And then what you do after that is you take the highest one. So your overall degree here is 4. Your overall degree here would be 6. So in this case, the degree of our polynomial here is 4. Now, the nice thing about degree is it actually tells you up to how many real solutions you can have. If you include complex solutions, so imaginary numbers, you would have exactly 4 solutions. Some could be repeats, I guess, but you could have 4 solutions there. So as you're solving this, just note that you could have up to 4 real solutions. So just kind of a nice little check. Now, we're going to solve by factoring. So the first thing you would do is take out the GCF. Both of these terms have a 3 there, and they also have x squared. So I'm going to factor that out first. And I'm left with x squared still, because 2 plus 2 would give me the 4. And then 27 divided by 3 is 9, and the x squared I already took out. Now you do want to keep factoring. Remember here, this is a difference of 2 squares. So that actually can factor. X squared is just x and x, and then 9 is 3 times 3. So when you have the difference of 2 squares, you just take your square roots and put a plus and minus sign in between to get your factors. Now, remember, if you need a factoring review, you can find that in section P5 of our text. And they do go through all the little factoring tricks, including difference of 2 squares, or you can check out my YouTube channel and get that review there for section P5 as well in the MAT162 class. Once you have everything factored, then like we did for quadratics, you can set each factor equal to 0. So I have 3x squared equal to 0, x plus 3 equals 0, and x minus 3 equals 0. And then you're going to solve each part. Now for the first one, we start by dividing by 3 on both sides, and we have x squared equal to 0. And then what you could do is you could take the square root here on both sides. So if I take the square root here and here, now technically there's a plus or minus when you do your square root, but 0 does not have a sign. So it's just x equals 0 for my first answer. Here I subtract 3 from both sides. So x equals -3. And here I add 3 on both sides. So x equals positive 3. Okay, so we have our 3 solutions. And of course, you could always check these by plugging them right back into the original problem. I'm not going to do that here. We've done lots of checks already, but just plug these answers back into the original and you should see you get true statements. 0 is an easy one to check, right? If I plug in 0 to my x's, they both become 0. So you can see right away that you get a true statement for that one. And then you can check the other ones on your own at home. All right, let's try another one. Okay, so same idea. We're going to find the degree and also solve by factoring here. So first thing I'm going to do is put this in standard form. So I need to bring the 4x over and the 4 over. And if it's positive over here, it's going to be a negative on the other side. So this becomes x cubed plus x squared. Now I'm subtracting this on both sides. So minus 4x, subtracting this on both sides, minus 4. And then you'll cancel them on the right to get that equal 0. For your degree, the degree of this piece is 3, looking at the exponent. Here's 2. This would be a 1, so there's always a 1 there. And here it would be 0. And then you take the highest one. So your degree overall in this case is 3. So what we would expect is up to 3 solutions here. Now, if you think about factoring, notice that I have 1, 2, 3, 4 terms. The easiest way to factor 4 terms is to use a strategy called factoring by grouping. And again, if it's been a while, go back and review those videos or go back and review that previous section. And what you do there is you actually group the first terms and the second terms together. So I rewrite the problem like this. So I'm just grouping my first terms and my second terms. I do like to have a plus sign in the middle. So I'm going to keep that negative with the 4 on the 4x there. But I haven't changed the problem. I'm just rewriting it. And now what you do is you take the GCF out of each group. So here our GCF is x squared. And when I factor that out, I'm left with x plus 1. Don't forget, if you have nothing left, you do have a factor of 1 there as your placeholder. And then here, I have a negative 4 in common. So I have x plus 1 again, once I divide that negative 4 out. You should have the same factor repeated here. So if you do, then you've done it right. And it's working out. So you're going to take that GCF out one more time, which is the x plus 1, and then you're going to write what's left over. So I have an x squared here and a negative 4 there. I'm just going to write it as minus 4 instead of plus negative 4. And now I do keep going because I can see I can factor this further. That's also a difference of 2 squares. So it's going to factor into x plus 2, x minus 2. And now I have, again, my 3 pieces here. So we're going to set each of those equal to 0 and go ahead and solve. So I subtract 1 in the first case, subtract 2 in the second case, and add 2 in the third case. Now I did say I could have up to 3 solutions here, up to 3, I should say, real number solutions, right? If you include the complex numbers, you would have exactly 3. In the last case, I said I could have up to 4 real solutions. So again, if you include complex numbers, you could have exactly 4. Here you actually do have 4 because this 0 is a repeat, right? Because technically it's plus or minus, but it's the same thing. It's just 0. So there's your 1, 2, 3, 4 solutions. All happen to be real. And then here you have your 3 solutions. And again, all happen to be real in this case. So this is how we can solve polynomials that are factorable. We just use those same techniques that we did when we had quadratics, which really are also a kind of polynomial. They're just of a lower degree. Not every polynomial is factorable, so this isn't going to work for every single case, of course, but for our purposes and in this section on the homework, if you see polynomials, you should really be thinking about factoring and how you can solve by factoring there. Now let's look at a different type of equation. And next we're going to do radical equations. So radical equations are equations that have some sort of variable under a square root, a cube root, or any higher root, a 4th root, 5th root, etc. So you see a root symbol or a radical symbol. When solving these style equations, what we basically do is raise both sides to the same power as the root to cancel it out. The problem here, though, and I've mentioned this in other previous strategies for solving things, is that it can create extraneous solutions. So you always want to check your solutions. Remember, extraneous solutions don't actually work. So when you plug them back in, you see that they're not really true solutions. This happens in general when we start multiplying by variables on both sides of the equation or raising variables to powers. Sometimes we get extra variables in there, which give us extra solutions. So anytime you use that sort of strategy, you're going to have to check your answers. So our process is to first rearrange the terms so that the radical is isolated. So this is different. We're not going to have necessarily an equal 0 side. We want that radical to be by itself. Then we're going to raise both sides of the equation to the same power to get rid of that root. So if it's a square root, you would raise them to 2. If it was a cube root, you would raise both sides to the 3rd power. A 4th root would be the 4th power, and so on. And then you're going to simplify. Now, if you have more than one radical to start with, you may still have radical left over after that step. So you're going to have to repeat that process again, and then keep solving until you get your answers. And of course, don't forget to check your answers. This is really important here, because you can get extraneous solutions. So let's do this one. My first step is I want to get the radical by itself. So I do want to get rid of this plus 2. So I'm going to move it to the other side to start. And I have square root of 2x minus 1 equals x minus 2. Now I want to cancel that radical. So just think about what kind of root you have. Here I have a square root, which is this would be a 2 here, right? So I'm going to raise both sides to the 2nd power. And that will cancel that radical part out for you. And you're left with just 2x minus 1 on the left side. Be careful though, x minus 2 squared, you have to FOIL that out. That's x minus 2 times x minus 2. So make sure you think about that. We're going to actually multiply that out. I have x squared minus 2x plus 4. Now I'm going to keep solving. So notice how my radicals are gone, which is really nice. That's our goal. And now we're going to combine like terms and then look and see what we have left. So here I have 2x minus 1, x squared, and over here I have a negative or minus 4x. I'm going to bring my 2x to the other side. And I'm going to add the 1 to the other side. And I'm left with 0 equals x squared minus 6x plus 4. So I was just getting all my like terms together on one side. And I am in standard form now. Notice that I have a polynomial here, or a quadratic in this case. So I do have a quadratic here. So I could go back and I can think of, okay, well, what kind of techniques can I use for my quadratic? So think about your quadratics. We did a factoring technique, we did the square root property, we did completing the square, and we did the quadratic formula. So you want to look through and see if any of these work best here. Oh, sorry, I wrote something wrong. That should be a 5. 4 plus 1 is 5. Sorry about that, I just caught that. And you're going to see which strategy works best in this case. So for me, I tend to like to try factoring first. I've been factoring a long time, so I can usually do it pretty quickly. So that tends to be my go-to strategy. The square root property doesn't work here because I have a 6x here in the middle. So that's not going to work. If you're stuck though, completing the square and the quadratic formula will always work. So you can always use those as well. Let's see, which strategy am I going to use? Looking back at my notes here. All right, I think I'm going to go ahead and factor. All right, so if I look at my factoring here and I actually go ahead and try out some values, well, x is only x times x, and 5 is only 1 times 5. So I don't have a lot of options here for the trial and error method. I do want a positive 5 and a negative 6 though, so the way to get that to work is to use 2 minus signs. If I multiply this back out, I will get x squared minus 5x minus 1x, and then plus 5. So it will match the original. Remember, if you're using the factoring technique, double check your factors before you go on. You don't want to factor and then get an answer and realize it's wrong because you made a mistake in your factors. So if you're, need a little bit more practice here, maybe take some time off to the side, re-multiply that out and make sure it matches your original. Once that's done, then all I do is I set each of these factors equal to 0, and I go ahead and solve. So I have two potential answers here, x equals 1 and x equals 5. I'm running out a little bit of space, so I'm just going to do my check up top. You really do have to check because you could get extraneous solutions. So I'm going to plug it back into the original problem. So 2 times 1 minus 1 plus 2 equals 1. So this is the square root of 2 times 1 is 2 minus 1 is 1. And I'm getting the square root of 1 is 1. So I'm getting 1 plus 2 equals 1. That doesn't make sense, right? 1 plus 2 should be 3. So this looks like it must be an extraneous solution, and I'm going to have to throw that one out. Now, that doesn't necessarily mean the other one always works. You still have to check the other one. 2 times 5 minus 1 plus 2 equals 5. Well, 2 times 5 is 10 minus 1 is 9. Square root of 9 is 3, and 3 plus 2 does actually equal 5. So it looks like I do have one solution here. And x equals 5 is going to be my only answer in this case. Okay, so always make sure to check. Sometimes they'll both work. Sometimes maybe one will work. Sometimes they both don't work and you have no solution. So it is important that you get used to checking. All right, and let's do one more. This one's clearly a lot harder. I have two radicals here. So when you have two radicals, you still want to isolate at least one radical to start with. So what I'm going to do is bring this one to the other side, and I can do it by addition. So I'm going to add this root on both sides. And it's going to give me 3x plus 1 on the left still. And then on the right, I'll have 1 plus the square root of x plus 4. Okay, so I'm just adding that root to the other side. And that's what you want to do to start. So if you have two radicals, then you're going to have to split them, put one on each side. And now you're going to cancel. Here I have a square root again. So I'm going to use a power of 2. And you're going to raise both sides of the equation. It's going to cancel it on the left. But squaring here means I'm going to have to FOIL. It's a little bit hard to FOIL with radicals, so I really suggest just taking your time and writing this out. So you're going to start with 1 times 1, which is 1. 1 times that square root of x plus 4. Now multiplying by 1 doesn't change anything, so it's just the square root of x plus 4. Same thing on the inside here. Multiplying by 1 isn't going to change it. And then you have root x plus 4 times root x plus 4, which is the same thing squared. Now notice here that I have the same root twice, so I can combine these. This is like combining like terms. We combine like roots as well. And again, there would just be a 1 out front here. So 1 plus 1 is 2. So basically I'm saying that I have 2 of these radicals. And then a square root and a square cancel. So this becomes x plus 4 on the end. I'm going to keep combining like terms. So let's see, I have the x here. I have 1 and 4 is now 5, and I have that 2 root x plus 4. And now I'm going to start moving things around. So I am going to bring my x over here. Let's subtract that from both sides. So 2x plus 1 equals 5 plus 2 root x plus 4. I'm also going to subtract the 5 from both sides. 2x minus 4 equals 2 root x plus 4. So I'm just getting all my like terms together here to try to clean this up a little bit. Now at this point, I do want to go back and repeat steps 1 and 2. So I'm going to try to isolate that root again. So you could leave the 2 here if you want to. I like to divide it out though. So I'm going to divide by that 2 on both sides. And then just remember when you're dividing, you divide it both ways. So 2 over 2 here cancels and I have x, and 4 divided by 2 here is 2. So I'm left with this. Now it's a square root, so I'm just going to repeat that process over again by squaring both sides. And remember, when you're squaring here, this is going to end up being a foiling problem on the left. So on the left, if I FOIL, I have x squared minus 2x plus 4. And on the right side, I'm left with just x plus 4. Combining like terms, I have x squared minus 4x plus 4 equals x plus 4. I'm going to bring my x over. Oops, equals, sorry, 4. And then I'm going to bring my 4 over. I'm just jumping ahead there. And I'm left with just x squared. Let's see, minus 5x equals 0. I see that I can go ahead and factor this. So I can take an x out first. I'm left with x minus 5 equals 0. And then I set each factor equal to 0. So here I have x equals 0 as one solution. And then here when I add 5 to both sides, I get x equals 5 as my other solution. But don't forget, you do have to go ahead and check this. And I do have to check them each separately. So I'm going to check x equals 0 first, and I go right back to the original equation. So you want to go back before you start squaring everything. So it's the square root of 3 times 0 plus 1 minus the square root of 0 plus 4 equals 1. Well, 3 times 0 is 0, plus 1 is 1. So I have square root of 1 minus 0 plus 4 is 4. And this becomes 1 minus 2, which is not positive 1, it's negative 1. So this is not working, which means that x equals 0 must be an extraneous solution here. Okay, let's try our other one. So now I'm plugging in the 5. So in the first case, I have 3 times 5 is 15 plus 1 is 16. So square root of 16. Here I have 5 plus 4 is 9. So square root of 9. Square root of 16 is 4. Square root of 9 is 3. And in fact, 4 minus 3 is 1. So I only have one solution here, and that's the x equals 5. So for your radicals, again, this was the hardest one because you have multiple radicals. So I had to do that squaring process twice. But the goal is to isolate the radical and then clear it out by using the same power as the index. So square roots, you use squares, cube roots, you use cubes, fourth roots, you use a fourth power, and so on.